Okay, 8.3 has to do with similar polygons. Okay, so this is going to relate to our ratios and proportions, and you'll see how it does that. So first, we're going to talk about similar polygons are. These are polygons that meet certain conditions. So they have congruent angles, and proportional sides. Proportional sides. And what proportional means, okay, proportional sides means that if I make a ratio between corresponding sides, that ratio will be the same for all sets of corresponding sides. Okay, so all corresponding sides make the same ratio. Okay, and this ratio that they have is the scale factor. So it's the constant ratio between corresponding sides in similar figures. Okay, so let's just look at what this means. So down here, this symbol here, it's like the squiggly on top of congruent, only it doesn't have the equals part underneath there, because congruent is really a combination of being similar, which is what this means. This means similar. And equal. Okay, so congruent means things are similar and they're equal. If you take away the equals, they're just similar, which means they look identical except they're different sizes. So if I tell you that FGHJ, which is this shape, is similar to KLMN, and they have a scale factor of 3 to 2, that means that if I pick corresponding sides, so FG corresponds to KL, so if I look at these two sides here, they have to make a ratio of 3 over 2. So 6 over something has to equal 3 over 2. Okay, and I can solve that to figure out what this is. Well, we could cross multiply, or we could just look, what am I doing to 3 to get 6? I'm multiplying by 2. So I'm going to do the same to the bottom. That's going to make this a 4. Okay? All of these sides have to have a 3 to 2 ratio. So here I've got 9. So 9 over what equals 3 over 2? Okay, and that'll tell me how long this is. Well, I'm timesing by 3. I'm going to times this by 3. 6. Here I've got 8. 8 over what is 3 over 2? Here I am going to cross multiply. So I'm going to get 3x equals 16. So x is 16 thirds. Okay, and this corresponds to this. So this would be 16 thirds. Okay, here I'd have 4 over something equals 3 over 2. Okay, so I'd have 8 equals 3x. So this is 8 thirds, the corresponding side. Okay, that's what similar means. And of course, all these angles would be congruent because the angles are really what defines the shape of the figure. Okay, if I had different angles. If I had different angles in here, I wouldn't have the same shape. Okay, because if one of these angles changed, that would change the configuration of the entire shape. It would change the lengths and everything. So angles are what defines the shape, and the lengths are what defines how big it is. So I could make any number of these same shapes. Okay, but my angles aren't changing. The only thing that's changing is how big the sides are. So it's the angles that are making the shape, the shape that it is. So similar has these two things, congruent angles and this constant ratio between the corresponding sides. In this case, it's a constant ratio of 3/2, which we call our scale factor. A similarity statement. Okay, every time you have similar figures, you can write a similarity statement, which is just a big proportion that compares all of the sides. So I can say that FG over KL is equal to GH over LM, which is equal to JH over NM, which is equal to FJ over KN. This is my similarity statement, and a lot of the problems in your packet are going to ask you to write one of these. What is the ratio of their perimeters? Let's think about this. I have a constant ratio between these and these. What I'm going to do to find the perimeters, I'm going to add all these up. And I'm going to add all these up. Okay, so I should have the same ratio between their perimeters. It should be 3/2. Let's make sure. Okay, here I'm going to have 6 plus 9 is 15, plus 8 is 23, plus 4 is 27. Here we're going to have 8 thirds plus 16 thirds. That's a total of 8 plus 16, 24 thirds. Okay, 24 thirds, which is 8 plus 6, 14, plus 4, 18. This, of course, reduces to, if I divide both by 3, I get 9/6. Divide by 3 again, I get 3/2. Okay, so the scale factor applies to not only the sides, but their perimeters as well. Okay, let's look at some examples like what you'll be expected to do. Okay, let's say these are similar. The way we're going to write that out is the same way that we had to write congruency statements. We need the pieces that are corresponding to have letters in the same order. So I'm going to start at B. I'm going to say B, C, D, E, A is similar to, here's B, it corresponds to N, so N has to go first. And from B I went to A, which was one of these shorter sides right before the same length. So I'm going to go from N to J to K. I'm going to go around the figure this way. So N, J, K, L, M. Because I need this statement to convey which pieces correspond. So I know that DE corresponds to KL. Okay, DE, KL. Now, what is the scale factor? What's the constant ratio that's happening here? I'm going to have to find two sides that correspond to each other and put them into a ratio. So if I wrote my similarity statement this way, okay, from this shape to that shape, I need my scale factor to be the same way. It's going from this shape to that shape, so it's going to be 2 to 3. I can use my scale factor then to find x. Okay, x corresponds to 6. So 6 over x has to equal, okay, 6 came from this shape, so I need the scale factor part that corresponds to this shape, which is the 2, to be across from it, and the 3 over here. Okay, and I can cross multiply, I'll get 18 equals 2x, so x equals 9. What is the similarity statement? I can get my similarity statement just from here. Okay, BC over NJ equals CD would be the next side over JK BE KL EA LM, and then don't forget to loop back around, so AB MN. That'd be your similarity statement. All right, now, are these triangles similar? Okay, that's what we need to ask ourselves. Well, in order to be similar, I need all the angles to be the same. I have one angle that's definitely the same, 45 and 45. This one's 90. That's going to make this one be 45 also. Okay? These two add up to something that isn't 90. Okay? These would add up to 99, which would leave 81 for this, which is not a right angle. Okay? So these triangles cannot be similar because their angles aren't all congruent. So even if I had proportional sides by some miracle, which wouldn't happen, okay, I couldn't say that these are similar. Okay, and you'll see that that's not a possibility to have proportional sides if you don't have congruent angles in a future section. Okay, so this is what you'll be doing for section 8.3.